Hey guys, welcome to U4L3 Factoring Quadratics to find their roots and their solutions. Here is your bell work for today. So, when you get done with this assignment, you should be able to solve for zeros by factoring. And I want to make sure you always read the directions, okay? Alright, so let's take a look. If you'll look, you got 3x plus 3 equals x plus 17. First thing you want to do is you want to combine like terms. So I'm going to combine my x. Notice I'm moving it across that equal sign. So I'm going to put minus x. I'm using the inverse. So now you got 2x plus 3 equals 17. Now I can solve for x. Subtract 3, subtract 3. 2x is equal to 14. Divide by 2. X is equal to 7. Okay? And if you were to check, you can plug in your 7. 3 times 7 plus 3. 3 times 7 is 21. 21 plus 3 is 24. Let's check over here. 7 plus 17 is 24. They are equal to each other, so your answer is correct. And there you have your solving the equation. Okay? All right. Now, just a little refresher course about what you guys learned yesterday. You were able to go from standard form to vertex form using the axis of symmetry, which is x equals negative b over 2a. And if you can't see that, let me write it just a little bit bigger. Okay? Or by completing the squares, which we are going to learn later. And to go from vertex to standard form, we are going to multiply. And so that was what we learned yesterday. Today, you are going to go from standard form to factor form, and by factoring. Just like that, the inverse of that, to go from factor form to standard, is also multiplication. All of this is all manipulation of math. Okay? Right. So let's take a look at our very first one. Here you have this equation. 6x squared plus 15x minus 36. Notice this is a quadratic trinomial. Highest degrees of 2, you got 3 terms. Your first thing you always want to do is read the direction. What did it ask you to find? It's asking you to solve, because I want to differentiate between the two, okay? Between solving and factoring. All right. First of all, what you need to do is you need to factor out your greatest common factor. Factoring is a division. What goes into 6, 15, and 36? Do they have anything in common? So 3. So I'm going to factor out a 3. So basically, you're dividing every one of these terms, term is separated by a plus or minus, by 3. So you factor out a 3 and you have 2x squared plus 5x minus 12 equals 0. Okay? And why do I want to factor? Because I want to deal with smaller numbers than with a bigger number, and that's why you want to factor. But if you forget to factor out your greatest common factor, you're going to have to do it later, but your numbers will be bigger. All right? Okay, bring down your 3. 1 term, 2 terms, 3 terms. So I'm going to break that down into 2 sets of factors. All right. So that 2 is going to come into play later. Okay? But for now, we're going to ignore it. X squared factors x and x. 2 times negative 12 is negative 24. All right. So what you want to do is you want to find 2 numbers that multiply to give you negative 24, and it's going to subtract to give you positive 5x. And how do I know to subtract? Because that's a minus. Okay? So that means one of your numbers is going to be a plus, the other one's going to be a minus. So what are my 2 numbers that multiply to give you 24 and is going to subtract to give you 5? That would be 3 and 8. And if you don't know, oops, I didn't know my drawer was locked. Let me get my calculator real quick. So this is, now in my class, I kind of expect you to know the small numbers. But if you didn't know the big ones, you would take 24, divide by x, and here's the x, and go to your table. Start at 0 where it says error. Try to find those numbers. See how 3 and 8 subtract to give you 5, okay? So those 2 numbers are going to be 3 and 8. It's a plus, so my big one's plus, bigger number, and the small one's going to be minus. And how do I know it is correct? Well, let's see. Plus, okay. Negative 3 times 8 is negative 24. Negative 3 plus 8 is positive 5. Do you see how it serves a dual purpose? Okay. All right. Okay. Next thing, see that 2? We'll bring out the 2. 2 and 2. All right. Now I'm going to pause for a little bit, okay? If I'm asking you to just show me a factor, and this equals 0 wasn't there, if this is just factored form, this is what I want you guys to do. All right, so you got your 3. 3 divided by 2 is not a whole number, so the bottom is going to come up. Did you guys see that? So you will have 2x minus 3. Okay? Next set of factors. X plus, what is 8 divided by 2? It is 4. This is the factor form. Hence what I just did. There's your factor form. Okay? Now, always check your numbers though. Always check to make sure it's right. You guys ready? 3 times 2, always check your first and last term. 3 times 2 is 6x. 6x times 1 is 6x squared. Did you see how it matches that? Check your last term also. 3 times negative 3 times 4 is negative 36. Don't worry about the middle, just those two parameters. Did you see how it matches up? So there's your factor form. I'm going to rewrite it because it looks bunched up. But that's not what I asked you to find, okay? What did I ask you guys to do? I asked you to solve. So if you're going to solve, I would do this. So I want to point out the difference. I'm going to rewrite it. Okay, you guys ready? If you were going to solve, do you see how there's no x with that one? 3 can never be equal to 0. So I can ignore it. So x minus 3 over 2 equal to 0. How do you solve for this? You add 3 over 2 to both sides. X is equal to 3 over 2. That means I'm going to cross the x-axis at 3/2. The other one, right here, x plus 4 equal to 0. X is equal to negative 4. There you have solving, and here you have your factor form. So just make sure you listen to the question or read the directions, okay? All right, this one says to solve, so the correct answer is this, not this. All right, next part, okay? Let's try this again. Here we go. 1, 2, 3, quadratic, okay? Nothing greatest common factor, so I'm going to go ahead and draw my 2 sets of parentheses, okay? You want a drink?
Yeah.
I got water.
No, it's okay.
It's okay? Okay. Factors of x squared, x and x. My apologies. 3 times 5 is positive 15. See how it's positive? I want to add 2 numbers to get me a positive 8x. Okay? What are those 3 numbers? 3 and 5. Plus 3 plus 5. 3 times 5 is positive 15. 3 plus 5 is positive 8. So we just got that? Okay. Now, see that 3 right here? You remember this 3? Divide each of these by 3. Let's read the direction. Find the roots. Okay, so I'm not factoring. I am just solving. So what do? X plus 1 equal to 0. Subtract x from negative 1 from both sides. This one here, x plus 5 over 3 equals 0. Subtract negative 5 over 3 for both sides, and there you have your zeros. Okay? So, but if I were you, I would always check the factor form to make sure I did it right. To make sure I have factored everything. Okay? So x plus 1, and then you got 3x plus 5. Let's check. X times 3x is 3x squared. Check. 1 times 5 is positive 5. Check. And so I know I have factored it correctly. Always check your math. Okay? All right. Take a look at the next example. Okay? What do we need to do to this one before we do anything with it? Well, it's not set equal to 0, so we need to add 20 to both sides. So now you got x squared plus 9x plus 20. Set that equal to 0. And the question says find the zeros. Count your terms. 1, 2, 3. It's a quadratic. In order, nothing missing. 2 sets of parentheses. Factors of x squared, x and x. What 2 numbers multiply to give you 20 and also going to add to give you 9. 4 and 5. So plus 4 plus 5. Your leading coefficients are 1, so you don't have to do anything. It says to find zeros. So x plus 4 equal to 0. X is equal to negative 4. X plus 5 equal to 0. X is equal to negative 5. Okay. Alrighty. Check your numbers. X times x, x squared, 4 times 5, positive 20. Good. Alright. Always check. Okay. Next equation. This is for you guys to try. Let's take a look at this one. Not in order. Let's put them in order. 14r squared minus 29r minus 15 equals 0. Anything greatest common factor? No. So I'm just going to draw my 2 sets of parentheses. Set it equal to 0. R and R. And that 14 is going to come back later. All right. 14 times negative 15. Okay, you ready? So here we go. Get out of that. Clear. 14 times negative 15 is negative 210. Since it's negative, I'm going to subtract 2 numbers. So what 2 numbers multiply to give you that, and is going to subtract to give you negative 15r. Here we go. Y equal 210 divided by x, second table, and I want to subtract, start where it says error, to get 15. Okay, that, nope. 15, nope. 15, nope. Huh. Oh, I am so sorry. I don't know why I said 15. I lied. To get negative 29r. No wonder. But I'm subtracting. These add up to be 29, but I'm not adding. I am subtracting. So what do I have? That is not either. That is 6 and 35. Good. And I want negative, so this is negative, and this is positive. Plus 6 minus 35. Okay, I'm going to go ahead and do the factor form. Divide by 14, divide by 14. Alrighty, here we go. Okay, so I'm going to simplify that. R, 6 divided by 14 is simplified. I'm going to divide each of these by 2. So you have 3 over 7. See that? I'm going to divide each of these by, they have a greatest common factor of 7. So r minus 5 over 2 equals 0. All right. Can I simplify this anymore? So bottom comes up, 7r plus 3. Can't do that either. 2r minus 5 equals 0. All right. Now let's go ahead and set this equal to 0. R minus 3. R is equal to negative 3 over 7. Okay, same thing over here. 2r minus 5 equals 0. 2r equals 5. R equals 5 divided by 2. There are your zeros. All right, let's go ahead and check at your factoring. This is the factor form. Okay, 7r times 2r is 14r squared. Perfect. 3 times negative 5 is negative 15. Perfect. All right, so you have done it correctly. Okay. Water?
Yeah.
Go get water. Okay. In my fridge. Go get water in my fridge. Okay. It's okay. Go get it in my fridge. All right. Okay, let's move on. All right, now let's take a look at this one. You have two terms.
Thank you.
You're welcome. You have x squared minus r. This is called differences. The word differences means subtract of perfect squares. Okay? Differences of perfect squares. And let me tell you why it's that. You got one term, two term. X squared is a perfect square. 9 is a perfect square of 3. See that minus between them? So this is a difference of perfect squares. Another way you would write this is x squared plus 0x minus 9 equals 0. And there's your three terms, okay? All right. So factors of x squared, x and x. Factors of 9, that's going to subtract to give you 0, minus 3 plus 3. Set each one equal to 0. Oops. X is equal to 3. X plus 3 equals 0. X is equal to negative 3. Now, since both of those are the same, one's plus, one's minus, you can actually write it plus or minus 3. Just like that. Okay? Those are perfect squares. If you can recognize perfect squares, it's pretty simple. All right. And why did I go ahead and finish it? Because it says find the roots. Otherwise, this would be your factor form. Okay? All right, let's go to the next one. All right, I'm going to go back to this real quick. Here you have factoring. But I'm going to show you a different way you can do this. You see how it says roots? So instead of factoring, I can also solve it a different way. So let me show you. X squared minus 9 equals 0. 1, 2. What if I were to add 9 to both sides? So x squared is equal to 9. How do you solve for x? Well, you can take a square root, okay? And when you square root something, you get two answers, plus or minus 3. Same answer, different method. This one is solving using two terms. This one is by factoring. It's up to you. Okay, if I had asked you for factored, this would be the factor form. If I say find the roots, this would be the answer. If I say do it by factoring, I have to do it this way. If not, you could do it this way. All right? Read the directions and follow the directions. Read the fine print. All right, next example. Perfect squares, not a perfect, but there's a minus. Now, read the directions. What did it say to do? Find the roots. So I'm just going to solve. Add 50 to both sides. X squared is equal to 50. Square root. Okay. When you square root, you have two answers. Now, I don't want to see a decimal, but within the 50, is there a perfect square anywhere? Yeah. There's a 25 times 2. See that right there? What is the square root of 25? Square root of 25 is the same as 5 times 5, right? So that 5 is going to come out because the square root of 25 is 5, and who's left behind? 2. And there's your solution. Okay? All right. Let's move along. Okay. Count your terms. 1, 2, 3. Not a quadratic. But is there anything that they have in common? Is there anything that goes into 9, 29, and 6? No. However, they all contain n squared. So could I factor out n squared? Yes. And once you do that, do you now have a quadratic? Right there. Okay. Can I now find the roots? Yes. Let me see if I can factor. Sounds good? Bring down that n squared, two sets of parentheses. Okay. That 9 is going to come later. N and n. 9 times 56, sorry, 9 times 6 is positive 54. And I want two numbers to add up to give me negative 29. Okay. All right, what are some numbers? If you don't know, go to your y equal. Okay, second table. So I want 29. Make sure I type it right. 3 and 18 is 21, 2 and 27. And both of these are going to be negative because that's a minus. Negative 2 minus 27 is negative 29. Negative 2 times that is plus 54. So minus 2 minus 27. Divide by the leading coefficient of 9. Now, read what it says. I'm finding the roots. Okay? So I'm going to go ahead and do it in factor form, just so you guys see. Here's my factored form. N squared. Negative 2 divided by 9, bottoms up. 9n minus 2. Negative 27 divided by 9 is negative 3 equals y. There's my factor form, okay? Now, you can use this to solve, or you can use this to solve. Okay, here we go. N, 1 times 9n is n to the third, times 1 more is 9n to the fourth. Check. N squared times negative 2 is negative 2n squared, times that is positive 6n squared. Check. So your factoring is correct. All right. Now, here is if I am to solve for roots. I can use this, or I can use this. So n squared equals 0. N minus 2 over 9 equals 0. N minus 27 over 9 equals 0. See how you're solving for roots? Okay, square root of 0 is 0. Multiplicity of 2, you don't need to tell me that, but you know it's going to be a bounce at your graph. Add 2 9s to both sides. There's your other x-intercept. Okay. Add 27 over 9 to the other side. And then 27 over 9 is 3, and there's your other intercept. 2, 3, 4 to the fourth power. There's your x-intercept. All right, not bad, right? Okay, let's go ahead and go to the next one. Now, how many terms do you see? 1, 2, 3. Is that a perfect square? What's the square root of that? 2x squared. 9. What's the square root of 9? Square root of 3 squared, correct? All right, now I want you guys to think about that middle term. It is not a minus. If it was a minus, you would have a plus or minus, and you would have had 2 terms. This is a 12. What is 2 times 3? That is 6x. Okay? If it is 6x, you always double. What does that come out to be? 12x. Do you see that? Little things I want you guys to notice. 3 terms, perfect, perfect. Do they multiply to give you that middle term? So let's factor and let you guys see. 2x, 2x, 3, and 3. Both of those are plus because it is all plus. All right, let's check. This is called perfect squares. Why are they called that? Because they're exactly the same. Okay? Multiplicity of 2. Here we go. 2x times 2x is 4x squared, right? 3 times that is positive 6x. And then you do the same thing, right? Times all of this. 2x times 3 is positive 6x. 3 times 3 is 9. 4x squared plus 12x plus 9 equals 0. Do you see how that checks out? Are you noticing how those are always the same? Okay. And if you really want to know, you can go 2 times 3 is 6, double it, and then you can just solve. All right. Let's go back real quick. So there you have your factor form. 2x plus 3 times 2x plus 3 equals 0. Solve. 2x plus 3 equals 0. Subtract 3. Divide by 2. There you have it. And if you want to write multiplicity of 2, you can. But you don't have to write numbers. It's going to bounce a negative 3 over 2, and you're done. Okay? Perfect square, perfect square. You multiply them and you double. If you notice it's that middle term,
perfect squares. Let's move on to the next bit. Alright, count your terms. 1, 2, 3, 4. Oh, not a trinomial and not a binomial. 4 terms. 3, 2, 1. Is that a quadratic? No. This one is actually a cubic. Okay? And we're going to do this by grouping. Here's your method. Group the first two together. Group the last two together. Make sure they're in your order. Okay, you guys ready? Factor out. Greatest common factor. 5x squared. From these two. When you do that, what do we have? X minus 5. Okay? Next group. What do those two have in common? See this plus? Bring that one down. 1. So you're going to factor a 1 from both those. When you do, you have x minus 5 equals y. Do you see how these two are exactly alike? Well, since they are alike, we are going to group them together as x minus 5. Okay? Do you see how these two are the oddballs? We're going to put those together and set that equal to 0. Okay, check the math. X times 5x squared is 5x to the third. Check. Negative 5 times 1 is negative 5. Check. Check the parameters. Okay. What did the question says? It says to find the root. Set this one equal to 0. X is equal to 5. Set this one equal to 0. X is equal to, let's see, 5x squared equals negative 1. X squared equals negative 1 over 5. Okay? So x is equal to plus or minus square root of negative 1 over 5. Alright. I'm going to take a second right now. Okay, I'm going to go ahead and show you guys this lesson, but we are going to be doing it on our own later. This right here is the same as plus or minus square root of negative 1 over square root of 5. Okay? You cannot have a square root in the denominator. So we have to call what's called rationalize. Is it time? Did you finish? Okay. See you later. Times 5 times square root of 5. And then we're going to multiply plus. Negative 1 times 5 is negative 5. Square root of 5 times square root of 5 is square root of 25. The square root of 25 is 5. Okay. Now, do you see how you have a negative under here? I'm going to show you something real quick. Square root of negative 1 is not a real number. This is the complex number I keep talking about. Okay? So here's your solution. Plus or minus I square root of 5 over 5. It's your root, but it doesn't cross the x-axis. And how many answers should we have? Fundamental theorem of algebra is 3, 1, 2, 3. I'm going to stop right there and I'm going to next one over.